Straight line lesson 6. So in our last lesson, I hope you remember that we learnt what a perpendicular bisector of a line was. We said it's when you have one line cutting another line at 90 degrees and cutting it exactly in half into two equal lengths there. Because from that, we could get from knowing the coordinates of the 2 points here, we could get the equation of this line here by working out the midpoint. And by taking this gradient, using the perpendicular gradient, and then using our favourite y minus b equals m bracket x minus a. We're going to learn today about two other lines that are quite crucial in this topic. In a triangle, we have a line called a median. On page 12 in your notes, that's a line, as you can see, coming down here from one corner, one vertex, to the midpoint of the other opposite side. So in other words, it cuts this side exactly in half. So again, it's going through the midpoint of the opposite side, but it's not going through at 90 degrees because it's going from the midpoint of this side to the opposite corner, the opposite vertex of the triangle. That's one example of the median. There are, of course, three, because I could also draw a line from the midpoint of this side across to this vertex, and from the midpoint of this side across to this vertex. And funnily enough, the three medians all meet at the same point. We'll come back to that in a wee minute. We also have the altitude of a triangle. Altitude, well, if this was the ground and this was coming vertically up here, it gives us the height. That's the altitude. Altitude connected with height here. Altitude, as again you can see, is going from one vertex here to the opposite side, but it's meeting the opposite side at 90 degrees. It is perpendicular to the opposite side. This is not the midpoint. These two sections, here are definitely not equal to one another. Classic mistake there. Okay, they're not halves because they are different lengths, but it is coming down at 90 degrees. On the median, we have a midpoint. So if we know corners and coordinates here, we can work out this point and use a point here and get gradient and so on. On here, we do not know the coordinates of this point, but we do know it's perpendicular, so we can use one gradient to get another. Again, if I drew in the three altitudes, so if I drew one from this vertex to the opposite side here at 90 degrees, and I could draw one from this vertex to the opposite side here at 90 degrees. And again, they all meet at the same point. Fancy word for that is they're concurrent. Again, more of that in a little minute. Perpendicular bisectors of a triangle go through the midpoint. So again, this is in half this time. This line is split in two with a midpoint here. And again, it's at 90 degrees. And so therefore it's not necessarily going through the opposite vertex up here. And again, we could have three perpendicular bisectors. We could draw one down here through the midpoint, coming down here, through the midpoint, coming down here. And you've guessed it, once again, they all meet. The three lines all cross at the same point. And then last but not least, angle bisector. I could draw a line through here, cutting this angle here in half, so that this is the same angle as this. Now, when we do this, if it's not an isosceles triangle, so just a normal random triangle here, we should say that these lengths here are not the same. They are not equal. Although that looks a bit like it in this diagram. All right, so this is not a midpoint. Okay. Angle bisectors, again, you can have three of them, one coming out from this vertex and another one from this vertex. Again, will all be concurrent, meeting at the same point, but are not so crucial, and in fact, we don't need to know about them for the course, but for your general interest and information. Three ways then. We can draw medians from the midpoint, median, but again connected to the average, middle to the opposite vertex. Altitudes at 90 degrees to the opposite vertex. Perpendicular bisectors through the midpoint at 90 degrees, not to the opposite vertex. Not normally anyway. And indeed angle bisectors. A little bit more information then if we go on to the next page. As we already said, medians are concurrent. They all meet at the centroid, so that's this point here. It's known as the centroid. All right. Again, interestingly, all right, the way these things are made, all right, when this point where the medians all intersect, it always divides each line into three. This is 1/3 of the way along this median. It's also 1/3 of the way up this median, and 1/3 of the way from this one. 1/3 from the side, 2/3 from the opposite vertex. Altitudes, again we said all meet here, and this is called the orthocenter. And finally here, perpendicular bisectors here meet at the circumcenter. We don't actually need to learn to memorize these names in terms of the higher course, all right, but as I say, to complete your knowledge. This is significant here. Circumcenter, right? Which one would we call the center of the triangle? This circumcenter here, so named because from this point, the corners, the vertices, are all the same distance away. In other words, if I had to draw a circle through that went through all 3 points here, this would have to be the center of the circle. All right, so any 3 points that are not in a straight line, we can actually draw a circle through by using the circumcenter. The circumcenter, though, I would argue is not the center of a triangle, as we might expect or in common usage, because the circumcenter, depending on the shape of the triangle, right, if it's a scaling triangle, circumcenter is normally outside the triangle. Other triangles it's inside, but it can be outside. Likewise, the orthocenter, where the altitudes meet, again in a scaling triangle, quite often the orthocenter is outside of the triangle and not inside as it is here. This centroid, the one where all the medians meet, actually, this is a good definition of the center because this is a balance point. Right? If I cut this shape out, or it was made from a heavier object, and I needed to balance it, where would I put the point of the pin underneath? This point would be the balance point. So that's that there. Again, these 3 names, the centroid, the orthocenter, and our circumcenter, are names that we don't need to memorize. But you should know that perpendicular bisectors always intersect, altitudes always intersect at the same point as each other, medians all intersect at the same point as each other. And again, just for interest, a very clever mathematician from Germany called Euler, all right, spelled E-U-L-E-R, proved that in fact, on any given triangle, unless it's equilateral, in which case these 3 points, the centroid, orthocenter, and circumcenter, are all in the same place. But any that's not equilateral, these 3 points, the centroid, orthocenter, and circumcenter, although they're in 3 different places, always lie on the same straight line. Again, purely for your interest. And again, something you don't need to know about at all, which we'll not be using after this, is the incenter is where, if we've got the angle bisectors, so these 2 angles are the same, these 2 angles are the same, and these 2 angles are the same, again, all meet at the same point, called the incenter. The incenter does not normally lie on the Euler line, all right, so it's entirely separate, and from now on it's not relevant to our course. How does it work? Well, let's look first of all at medians. Like finding a median. Here's an example. Find the equation of the median of a triangle through, and then we're listing the 3 sets of coordinates of the points, point A, point B, and point C. And we want the equation of the median. There are 3 medians, but it's the median that goes through the corner A. All right. First of all, do a sketch. Does not have to be hyper accurate, all right, but something that lets us see what's going on. All right, so I'm just going to say roughly, okay, A is the 0.68. So let's say I've not got a scale on here. I'm not measuring this other bit, say 6. So further up than along, something like here. Okay, let's call this A. B is -40. Oh, okay, so it's on the x-axis. So again, well, if that's 6 along there, I will say B is roughly here. So I'll call that point B. And C is 2, -2. So, well, if that's 6 along, about a third of the way down, something like here. And sketching what we've got here. So there we go. There's A to C, AB, BC. And the question says the median which goes through A. So from A to the middle of the opposite side. So something like here. That will be the midpoint that we're talking about here. So I'm going to call that capital M. If I was having to do other medians, I might call it M1 and M2 or so on. But just, it's only this line here. So we're looking for the definition of AM. And I'm going to try not to put it through the origin here, which would have been quite easy to do, because there's no guarantee that it does go through the origin. So I'm not saying that this line goes through the origin. So you can see my sketch, it goes slightly to one side there. And I'm going to try and work out the equation of AM, all right? And I know that these two lengths are equal. So I'm going to need to know two things for the equation of a line, as always, the gradient and a point on the line. We have a point on the line. We know the coordinates of A here, 6, 8. So what I need to do now is say, well, how can I work out the gradient? Remember our 5 methods. Method 1, change in y over change in x. Oh, we could use that. Because although I don't know the coordinates of M right now, we considered last time how to work out M. I know the coordinates of B. I know the coordinates of C. So I can work out the coordinates of M. That will give me the gradient. And then I can use y minus b equals m bracket x minus a. Oh, and I could use the coordinates of A or indeed the coordinates of the midpoint. It won't make any difference. So let's go with that. The midpoint. M is the average between B and C. If you want a working line in here, the average of the x-coordinate, so it's -4 plus 2 over 2 because it's 2 points. The average of the y-coordinate, 0 and -2. But give me M. Or indeed, you might just jump straight to the answer, which is perfectly acceptable. I have to say what's halfway between -4 and +2. All right, or do the calculation. -4 plus 2 is -2 over 2 is -1. And in the same way here, oh, is also -1. So as I say, if you jump straight to that answer because you can look at the coordinates of these points and that makes sense to you, great. We need gradient. So small m for gradient, the gradient, beg your pardon, of AM, A to the midpoint, capital M, change in y over change in x. Okay, so change in y, 8 take away -1, over change in x, 6 take away -1, (9/7). Okay. As I say, I can choose either point, this one here, -1, -1, or this point here, 6, 8. All right. Some will use the -1, -1 because they'll say they're smaller figures. Some will use the 6, 8 because they'll say they're positive. Doesn't matter. So y take away b equals gradient bracket x take away a. Remember, y-coordinate with the y, x-coordinate with the x. I'm going to use the -1 and -1. So y take away negative 1 equals 9 over 7 x take away negative 1, y plus 1 equals 9 over 7 x plus 1. Get rid of the fraction first, the 7 down here. 7y plus 7 equals 9 x plus 1, which takes me to 7y plus 7 equals 9x plus 9. Change it to the standard form. 9x plus 9 equals 7x plus 7. 7y plus 7. Pull everything to the one side. 9x minus 7y. Take away 7 gives me plus 2 equals 0. And there we've found the equation of this particular median. So to recap, we know we need the gradient to the point on the line. This is a midpoint, so we know that's the average of the x coordinates between B and C. The average of the y coordinates gives me the coordinates of the midpoint. Work out the gradient, changing y over changing x. Plug either point plus the gradient into y minus b equals mx minus a. Break the brackets, tidy it up. There we go. That's how to get the equation of a median. What about if we have to work out the equation of an altitude? And so this one goes. Again, sketch, very useful to see what's going on. So, information on this one. This is on page 14 of your notes. Triangle is vertices 6, 6, negative 3, 0, 0, negative 3. All right, I'm going to call this one here. All right, that's my point B, negative 3, 0. Oh, and C is going to be about the same distance down, roughly. So that will be C, 0, negative 3. And the question says A is at 6, 6, so somewhere over here. Again, I'm going to just draw it in. I'm not saying that anything is in any particular place here. So I'm going to draw it with my altitude here at 90 degrees to the opposite side. So this one here, lots of different lines going across the way. So there is my altitude. The altitude, the question says, okay, now there's a choice of different ones, but the question said the altitude through A. That means this angle must be 90 degrees. How am I going to calculate this? I need a gradient and a point on the line. I have a point on the line. How do I get the gradient? Well, I know the coordinates of B and C, so I can work out the gradient of BC, and then I've got the perpendicular line. And I know how to do that. So here we go. Gradient of BC, change in y over change in x. Okay. Minus 3, take away 0, over 0, take away minus 3. Minus 3 over plus 3, negative 1. There we go. I'm going to use the fact that we're talking about perpendicular gradients, so I write that down to show where it comes from. M1, M2 equals negative 1. So what's the opposite of minus 1 or negative 1? Turn it upside down, it's just 1, and swap the sign, plus 1. Okay, so I'll call this gradient. I'm going to put a subscript here, ALT for altitude. It's as easy as anything. Okay, because I don't have a letter down here. So gradient altitude, is +1. This is going to work out nice and easily. Point on the line, I know that A is 6, 6 from the question. So y minus b equals m bracket x minus a. Y, take away the y coordinate 6, is 1. X, take away the x coordinate 6. Okay. Y minus 6 equals x minus 6. Add 6 to both sides. Y equals x. That is of the form y equals mx plus c. It's just that m equals 1 and c is 0. So that's an acceptable form of the answer. So for altitudes, can't work out the coordinates of this point, but because it's an altitude, it must be perpendicular. So work out the gradient of the opposite side. Work out the perpendicular gradient. Use the vertex up here. Plug into y minus b equals mx minus a. And that's how we get the equation of medians and altitudes. Those two things, coupled with what we said last time, how to get the equation of a perpendicular bisector, we need to know all three things and how to do any given one at any particular time. And that's lesson 6.